I'm on number 4. There we go. That was great. Next, Kobus Greyling. You have to follow this person on LinkedIn. I do a lot of on LinkedIn, but Kobus, man, you're just pumping stuff out there, good stuff as well. So Kobus is Chief Evangelist at Human First. He will be speaking to us about the large language model landscape and different approaches to building applications. So please welcome him. Thank you so much.
I asked Sydney last night what will happen to a speaker if they go over time, and Sydney said they'll be walked off the stage. So I'm just going to keep on going until Prof. Steyn gets up, and then I'll stop speaking. So for the last few years, I try and write one Medium post every day. And I realized two things. To do that, you need content, and activity creates content. So if you really prototype, build working wireframes and prototypes, you create knowledge and content, and that helps with that challenge. And secondly, I realized that clarity is kindness. And if people find something clear, then they experience that writing as kind, and they come back for more content. And to make something clear, you've got to really understand it yourself, and you've got to put it in the simplest terms. So something that really interested me in the last few months is large language models. Now, is Jade in the room? She's the one person that will definitely keep me honest. But there's so much misconception around large language models, and so I just briefly want to touch on the large language model landscape. And then secondly, how to harness it, how to create generative apps. So there's so much talk about gen apps, generative apps, large language-based applications, and how are people harnessing that power. So this is version 1 of my slides. I sent version 2 this morning. I can share that with you later on. Things change so rapidly that my slide was outdated since I've sent it in 2 or 3 weeks ago. The timer stopped just in case I go over time. Anyway, so this is a rough overview of the large language model landscape, and you'll see, so it ripples out, and large language models have different functionality. Everyone talks about generation, text generation, summarization, but there are quite a few other aspects as well, like classification, translation. And what I find interesting, and then the next sphere is there you'll find the different models, and then from there, the tooling. So the models are growing rapidly. So the big providers like OpenAI, AI21 Labs, Cohere, they are releasing more and more models, and also deprecating models. But what's also interesting is that the tooling landscape is changing all the time. And I'll get to it in a brief moment, but what I find interesting about the tooling landscape is that many companies, many startups are being superseded by functionality that's now baked into the large language model. So it's analogous to guys making lots of money with the iOS flashlight app. And then when Apple included the flashlight in iOS baked in, those companies became, closed down. So already now you see companies, startups close down because the large language models are including that functionality in the basic offering. So this is again, I've got an update on this. So in my attempt to make sense of things, I created this foundation large language model stack. And these are most of the players in this space. So I've got to add some of the sponsors as well. My apologies. So at the bottom you'll see the foundation models, and that's not up to date. There are quite a few others. On top of that, there's the tooling data tooling environment, vector databases, semantic search, and it goes up until you find at the top writing assistants, etc., etc. So what you want to do as a business is get as low down as possible in that stack. Just recently, a Danish startup that was in the top 2 tiers, you could say, of that product landscape closed doors. Jasper, you'll see there at the right, under content and idea creation, they laid off about 40% of their staff recently. So you see quite a few of those top companies being superseded by basic functionality. So you really want to get, as a company, as low down as possible in that stack to add more value and not, not be superseded. Something I really find interesting, so with the advent of large language models, there was a lot of focus on fine-tuning the large language models. But there were a few challenges with fine-tuning. So fine-tuning is expensive in terms of you've got to prepare. It's expensive in the cost to the large language model because you pay for the fine-tuning. There's latency issues, especially if you have customer-facing applications. Thirdly, your fine-tuned model is frozen in time, right? So if something changes in the environment, then that model is fixed in time. I think the biggest problem for tech companies also is you are then connected to one large language model. So you can't really chop and change large language models. So because you've got all these custom fine-tuned models sitting with a provider, and so we've seen that there's been a lot of focus on prompt engineering. So let me just say this: so that the challenge I think with large language models, if you think of chatbots in general, right, we want to, as humans, communicate in an unstructured fashion. So we want to speak, and then we want to be communicated to in an unstructured fashion. So someone speak back to us. When you have a chatbot, you speak, you interact with the chatbot in natural language, so that's unstructured. Within the chatbot, you've got to structure the unstructured data, do all your API calls and things, and then unstructure your data again into a conversation to speak back to the user. With LLMs, everything is unstructured. So you interact with the LLM in an unstructured fashion via prompt engineering. So prompt engineering is really unstructured, and it's an example you give the LLM to mimic. And when the LLM responds, it responds in natural language, it generates. So it's fine for end users, but to build an application, you've got to take into consideration that the input is unstructured to the LLM and the output is also unstructured. So there's been massive focus on prompt engineering and very successful focus in leveraging prompt engineering to use models per default. And I'll argue anyone on that. Everyone talks about hallucination, right? So all hallucination is that the LLM is trying to give you an answer to your question, and it uses the data available. So any conversation we have as humans, context is really important, right? If there's a conversation, even in the house, if you don't have context, there's room for misinterpretation. You could call that hallucination. But once you have context, then it's much easier. So we've done quite a few tests, and with prompt engineering, you can negate hallucination by doing one thing: giving the large language model context at inference. If you do that, there's no hallucination. Also, with context, we've found that you can really use models, open source models, very effectively. So if you just casually chat with OpenAI, you'll say, well, it's significantly better than any other model like Bloom on Hugging Face. But once you start giving context, you realize, well, this model can work for me. So we've done quite a few tests, and we found quite a few open source models on Hugging Face using the inference API works quite well for us. But what I like about this graph is, you can have very little complexity, but then you have very little flexibility. So when you start off small with a static prompt, that's very simple. There's no complexity, but you don't have flexibility. And as you scale for an enterprise implementation, as you scale your flexibility, you'll find your complexity also increases, and that's the challenge. So for most enterprise applications, it's easy to start off, but once you see, but I want to add flexibility, the complexity increases. So normally it starts off with static prompts. That's not enough, right? So then you create prompt templates. Prompt templates is basically when you have placeholders or variables in your prompt. Then you start composing different prompts. Number 4 is you create contextual prompts. And number 5 is very interesting. So then people start chaining prompts together to create a larger application. So if you want to experiment with prompt chaining, there are 2 tools, Flowwise and Langflow, which are open source. You can run it on any laptop. And those are really prompt chaining tools, which you can reference quite a few large language models. And then something that's all the rage of late is RAG, Retrieval Augmented Generation. And basically all RAG is, when you submit your prompt at inference time, you give highly contextual reference data to the large language model based on what the user's query is. Autonomous agents is something that really excites me. You can really, using LangChain, you can create an amazing autonomous agent with different tools it can access. Recently, we built a prototype where we had 2 agents talking to each other, discussing the pros and cons of AI. That can get very expensive, so you must put a cap on it, because every call to the large language model potentially costs you money. But autonomous agents are really something very exciting, and it's something you can have a conversation with that system. And again, I like products and startups. My claim to fame is I've worked for 3 failed startups, and I'm working for my 4th startup now, so it's all going to change now. But these are the companies, some of the companies that really find themselves in that ecosystem. So you'll see the companies build up Flux, with static prompts, prompt stacks, and you see companies along the way. What's interesting, quite a few traditional chatbot companies like BotPress and Flowwise, VoiceFlow, they are retreading. It's almost like when project managers became coaches, agile coaches. So many chatbot frameworks are retreading as prompt chaining chain builders. And then what's also interesting, you'll see Vellum and Baseplate. Those are Y Combinator-backed companies. So they started off just as a contextual prompt building tool, and now they've moved into prompt chaining. So invariably, you find these companies moving up in that, call it value chain, because the higher you're up, the more value you can add. The vector embeddings, semantic search, those products assist RAG. So those products, those are vector databases or vector stores. So you can take any information of your company, chunk it, load it into those vector stores, and that information will be, those chunks of information will be extracted via semantic search. So something similar, the information that's similar to the user's query will be extracted, and that can be injected or embedded in the prompt. So there's been a small explosion regarding vector stores and vector embeddings. I think the most well-known ones there, I think Pinecone is probably the most well-known one, but there are quite a few other companies. So you see this focus of getting the context right. Getting the context right and ensuring the right contextual information is delivered at inference. Something also I find very interesting is the different prompt engineering techniques. And this you can play with in any playground of any large language model. And I'll be around the whole day. I've got notebooks on all of this, working examples. I'll gladly share it with you. But what's interesting is that there are so many, almost every month, a new paper comes out with how large language models can be prompted and queried. So I think the latest one is the self-ask, where someone developed a way, and there's no technical expertise required. But so anyone in this room can play around with it. But so self-ask is one of the newer techniques where you can actually coach or guide the large language model via prompt to ask itself questions, to answer, reflect, and ask the question back to itself. I think the most important one for me there is the meta prompt, where you try and have one prompt that's very flexible with placeholders, basically a template, to handle most of your queries. And then I think chain of thought is really important. So chain of thought really mimics the way we as humans think and reason. So chain of thought helps the large language model to break a bigger task into subtasks and then ask those questions, and then ask that questions to itself and then answer those questions. Just a summary in terms of prompt engineering, prompt composition, the different, so the previous slide was the different techniques. These are, just how the prompts are put together. Prompt composition is also something LangChain is pioneering, putting different prompts, concatenating the different prompts together. I think what I really find interesting is the prompt chaining, chaining a prompt in a flow. So that's analogous to creating a dialogue flow, in traditional chatbot terms. And then also the prompt pipelines. And if you want to experiment with prompt pipelines, there's an open source framework called Haystack. It's by a German company called DeepSet. So prompt pipelines is really a way to create a pipeline when you get a query to sequentially find different sources of information, perhaps summarize those sources and put it all together in one prompt to submit to the large language model. This is dialogue state management. What I find interesting about traditional chatbots, and I've worked on chatbots for a large portion of my career, the only AI in chatbots are really the NLU up front. The flow is a state machine, right? So the flow is basically logic gate state machine you build out. There's no AI involved in it, and everyone tried to unstructure or make the flow more flexible. So we had traditional NLU, dialogue state management, knowledge bases, semantic search like IBM Watson, Discovery, came in to act as a knowledge base. Oracle pioneered quick reply and tense. Rasa came with machine learning stories, which was really the first step into unstructuring. We get into large language models, and now we're seeing with prompt chaining and large language model agents that it's really becoming feasible. And I often ask this question on LinkedIn, and the feedback I get is that most people have not implemented this yet. So it's still very nascent, but prompt chaining and LLM agents, that's the way to really make the dialogue unstructured but still programmable. Prompt chaining, just briefly, the advantages of prompt chaining. So prompt chaining is when you actually build out a flow with different prompts and you connect those prompts. So there's also, so you could say prompt chaining is in stark contrast to LLM agents, autonomous agents. But what's convenient about prompt chaining is that you can really compare parallel streams. It's easier to debug. It's easier to isolate and perform unit tests. And again, to experiment with prompt chaining, you can use something like BotPress or VoiceFlow or FlowWise, LangFlow. I'll give you the names. There are quite a few free environments, no-code environments you can experiment with. So I think, for any company that wants to pivot from traditional chatbots to a more flexible generative approach with large language models, prompt chaining is definitely an option. And then in the last minute, NLU, natural language understanding. So this is the AI or the brain of traditional chatbots. And we did this study with Deloitte, and we confirmed that there's definitely still a place for NLU. So if you have any conversational data, any dialogues, any customer conversations you want to classify and divide into intents, traditional NLU is still your friend. I know Cohere's got a dashboard. I think Cohere is the only large language model where you can have classification. But if you want to classify text into, as we know it in chatbot language, intents, then NLU is still the option. NLU can run independently on your machine. There are many open source, very good pipelines. There are no-code environments. And there are still a lot of innovation around intents, so sub-intents, nested intents. So I always say don't discard traditional NLU. If you want to classify conversations, if you want to build a Gen app, LLM-based conversational interface, it would make sense to perhaps consider NLU for classification. And that's it from my side.
Thank you, Cobus. I had no need to forcefully remove you from the stage.
I'm happy.
This was so interesting, and I wanted to ask Sydney, and I'm sure the answer is yes, but I assume the slides of today will be shared with the delegates afterward, because I definitely want to get my hand on these slides, and I'll also have a look at your website. It was really good. Cobus, thank you so much.
Thank you.
Question or two from the audience for Cobus. There's one there at the back. There's the mic.
Cobus, first of all, thank you for your work and the amount of content you put out there. I think when the next static models are trained, they can learn from someone like you about the value of open sourcing and clarity being kind. So it's a service to the whole community and all customers, actually.
Thank you.
So when prompt engineering, you can have explicit instruction, examples, and then negative examples. So how do you weight those? So let's say you want to cover edge cases that you have to have specific rules for, like emotional distress or something like that, whatever it is. And then you also want to apply training prompt examples which give like richness to what generative AI can do, which is a variability and variation within the structure. But I've seen that they respond differently to like explicit instruction, and some want more examples. So what have you found in terms of weighting in that limited prompt engineering you can do to pay more attention to, so it can be both responsible and rich in its responses?
That's a tough question. Maybe just in short, because LLMs are non-deterministic, you can have like 10 different responses on 10 different prompts, same model, the same prompt. So two things we've been doing is that the one is we really try and make the prompt as descriptive as possible. But then a problem with that comes latency, and with that comes cost, because the amount of tokens you use. But we've also we also look at to observe, inspect, and tune. So there's got to be that feedback loop where you're able to inspect the input and the output, to observe it, to be able to drill down and inspect, and then to fine-tune that process as it goes along. Unfortunately, it's got to go live or get real-world interaction. So that's a loop, that observe, inspect, fine-tune. That's a loop we've been trying to refine just to improve that cycle.
I think there's a gap for framework models for inspecting and seeing how do you actually identify what needs to improve, as opposed to just looking at it.
We must chat afterwards. That sounds interesting. Thanks.
Cobus, thank you so much. Let's give him a hand. It was so